Right. Good morning, everyone, and thank you for joining us here today for this webinar, Maximizing Value Through Early Stage Carbon Optioneering. We're excited to be joined by one of our customers, Chapmanbdsp. And so just a quick overview of the session. We're going to hear from Chapmanbdsp about the work that they're doing with clients to carry out early stage carbon assessments and the methodologies that they're using. So I myself will then show a quick demonstration of the One Click LCA Carbon Designer 3D tool. So you can see how this is enabling the Chapmanbdsp team and other customers with their early stage carbon analysis. We'll then hand back to our guest speakers to take us through some real life examples of projects that they're working on and the results that they're seeing. Finally, we'll hand over to our audience for a live Q&A. So please go ahead and add any questions that you have into the Q&A box at any point during the session. And we'll answer as many of those questions as possible at the very end. So a quick overview of of One Click LCA, of who One Click LCA is. We're a global end-to-end sustainability platform for construction projects and products with the mission to power makers of a zero carbon future. You can learn more about who we are and the work we do and who we work with at oneclicklca.com. So my name's Samuel Boswell. I'm a business developer at One Click LCA, and I'll now let Holly and Max introduce themselves. So Holly, if you go first.
Hi everyone, so I'm Holly. I'm a senior environmental consultant at Chapmanbdsp, and I focus on lots of different services that we provide, one of which is embodied carbon analysis.
Yep, and hello, Max Chapmanbdsp, senior environmental consultant. Basically for the last 6 years, I reckon, I've been doing the whole life embodied carbon and circularity exercises, but for a range of different things, hospitals, offices, mixed use, you name it. And yeah, look forward to going through some of the examples with you.
Brilliant. All right. Well, I'll now hand it over to our guest speakers to kick off the session. And yeah, off you go.
Thank you. So Sam's already given us a great introduction, but today we'll be talking about how you can be maximizing value through early stage carbon optioneering. And we'll talk through a bit of an introduction of who Chapmanbdsp are, what project experience we have in relation to embodied carbon analysis, a bit of context around where we see the industry at the moment and why we think it's important to be doing this optioneering. And then we'll talk through a bit of a methodology on how we see you could be approaching this early stage carbon optioneering. And then we'll hand back to Sam for his demo. And then Max will be talking you through some case studies that we've got in relation to early stage carbon optioneering. So who are Chapmanbdsp? So primarily we are a building services and environmental consultancy. We have over 50 years of experience and we are an independent international consultancy. We've delivered small to large scale projects in more than 30 countries across a wide range of sectors, and our key services include MEP, sustainability and vertical transport. Everything we do at Chapman's is underpinned by our 3 core values, and that is to imagine the possibilities, focus on the future and deliver the vision. And a prime example of that is the London 2012 velodrome that you can see pictured, and that's one of our flagship projects. So what is Chapmanbdsp's approach to sustainability? So we believe that sustainability is a holistic approach. However, our key services are focused on energy, which is in the yellow, and then we've got certification in the green, and then carbon in the blue. So today's webinar will be focusing on the embodied carbon analysis aspect of our work, and some examples of embodied carbon projects we've worked on are these 6 pictured here. So I'm not going to talk through every single one of them, but it's just to show that we've got a real mix of use types, so offices, residential. We also do student accommodation, data centers, as well as lots of different strategies around their buildings. So is it a new build? Is it a major refurbishment? Is it a minor refurbishment? Some key ones to point out is Angel Square at the bottom middle. So that picture is actually, I took that myself. So you can see the retained structure in the picture there that they'll be reusing. Another good example is 81 Newgate Street in the bottom right. That is a major refurbishment where they're taking the existing facade down, they're reconditioning it, and then they're replacing it into the new building. So that's a great story in terms of embodied carbon and reuse. So why is it important? We'll be talking through a bit of context around why early stage carbon optioneering is important. So at the global scale, construction accounts for 39% of global carbon emissions, which is absolutely massive. I read an article the other day that was saying that that's equivalent to building Greater London every 6 weeks, which is just crazy. And construction emissions are generally split between embodied carbon and operational carbon. So embodied carbon accounts for 11% of global carbon emissions, and that comes from your material manufacturing, transport, your construction, and end of life, whereas operational carbon is more focused on how the building is being used, so any energy related to its heating and its cooling. And typically, the industry was focused in the past much more on operational carbon, and there's lots of guidance and policy around that already in place. However, in the UK at least, the grid is decarbonising, and we expect it to be net zero by 2050. And so we see there's this real shift happening in the market from operational carbon over to embodied carbon. And it's going to become more and more dominant moving forward. And we've seen that in the policy as well. So there's a real shift in policy towards embodied carbon. So I'll talk you through some of the key documents at the moment. So the RICS V1 whole life carbon methodology that came out in 2017, and that was a real fundamental piece that underpinned all of the methodology to follow, at least in the UK. And that was followed up by the GLA has its own guidance, it has its whole life carbon guidance and its circular economy guidance. There's been lots of different versions of that, but the latest came out in March 2022. The City of London then came out with its own planning advice note, which is specifically focused on carbon optioneering. And then recently, RICS have also released their V2, so their updated V1. That actually came out in 2023, but it became effective as of last month, July 2024. So you can see there's this real shift towards more and more embodied carbon policies coming out. Looking forward to the future, we also see more and more policies to come. For example, we know that Westminster and Camden Council currently revising their local plans, both of which are putting in a retrofit first appraisal requirement. So we definitely see there's this shift happening. And we think it's important to acknowledge if there's this shift happening in policy, then there could also be this shift happening towards carbon offsetting as well. So currently, operational carbon offsetting is the main requirement. Most commonly, the GLA require £95 per tonne of carbon to be offset, and that's mandatory. But there's no requirement at the moment for any embodied carbon offsetting in the industry. But if we're to follow the pattern of shifting from energy to carbon in policy, there's no reason why that can't happen for carbon offsetting. And with the price of carbon offsetting increasing every single year, then that may be that you're maximizing your carbon offsetting potential is going to become more and more cost effective. So if carbon offsetting is becoming more and more important and you really need to maximize your carbon offsetting potential, how can you do that? So this diagram is looking at over the project life, you've got a balance between the accuracy of your assessment and the ability to influence your whole life carbon. So you can see that the earlier you do your assessments, although accuracy is at its lowest, the ability to influence is at its greatest. And that's why we think there's a real urge to do this as early as you can in the project to maximize your influence. And I think it's important that you focus not on absolute numbers at this stage, but more on the numbers relative to one another and the comparison of one another rather than the absolute figures, because we know that the accuracy is lower earlier on. So I think that's, in summary, why we should be doing early stage carbon optioneering. And the main obstacle is that there's this lack of information. So how can we get around this lack of information and build up a methodology to approach these early stage models? So we see one approach being where you have no cost plan, you have very little design information available. You could use One Click LCA's Carbon Designer or Carbon Designer 3D, which is a very simple tool, requires very little input information. You basically need your use type, your area, number of stories, your frame type if you know it, and then very rough massing like your height and your width and things like that. And then One Click can generate all of the typical areas based off of their database. And that gives you that bare bones model that you can start layering on with any additional information you have. So we would take that bare bone LCA, One Click LCA model, and we would start layering it with any information that we do have. So that could be from your MEP team. If you know the system type already, or you know the capacities, then you can take out the ones that One Click have assumed and put in the ones that are specific to your project. And that applies to any kind of discipline. So all of your structural information, which often is very detailed very early on. You can take out all of your assumptions and put in your more accurate structural reinforcement quantities or your structural steel and things like that. The same with your architectural details. You can fill in any facade breakdowns that you know, or in any of your internal finishes. And I think it's important to know that you need to be very transparent on where all of your data is coming from, because say you have your architectural information is very high level, whereas your structural information is very detailed. You don't want there to be an imbalance in your information where the structural carbon is bigger because you just know more about it, and then your architectural information seems very light touch, but that's just because of the data behind it. So you need to be very transparent about the methodology that you're applying across it. And I think another good thing is to be clear from the outset that you're going to be looking at those relative numbers instead of the absolute numbers, because your design team can often be reluctant to provide data because they don't want to be confined to their early assumptions. If their assumptions change and the numbers increase, they don't want to be put at risk. So layering all that information together, that builds us towards our initial early stage model. And then we can take that, we've increased the reliability and the effectiveness through layering the data, and that gives us our model we can start doing optioneering on. And then I think Sam is going to hand over and give you a little demo of this in practice.
Yeah, thanks, Ollie. I will now share my screen and very quickly run through the Carbon Designer 3D tool. Here we go. So I'll just wait, and because I think there's a slight delay in the screen arriving. So maybe if Max, okay, thumbs up, good. So you can see I'm on the project homepage here. This is the demo project that I have. We have the standard user interface with the general information about my project. We've got an overview of results as well as the One Click LCA Carbon Heroes benchmarking tool. And then below that, we've got the designs. So in this project, I've got 4 designs. I have a option 1 baseline, option 2, option 3, which is a retrofit, and then I have an option 4 here. The calculation tools that I'm using, lifecycle costing, MEP tool, BREEAM, biodiversity net gain, as well as the RICS tools and building circularity. So to access Carbon Designer 3D, you click this button here, and then it offers whichever calculation tools are relevant for that. So I'll use the BREEAM UK for this one, and I already have one made here. So it then brings us onto this interface where we start inputting the data. And so at this point, I can either choose a design that I've done before, or in this case, I'll create a new design. And so the first thing it asks us for is just some general information. So it'll ask for a name. So I'll say One Click LCA, Carbon Designer 3D demo. We then choose a reference building. So of course, if the building's based in the UK, we choose this. I'll explain a bit more about the reference building later on. We can then choose the building type. So it goes from data centers, warehouses, hospitals, cultural buildings, even one dwelling buildings. In this case, I'll choose an office building. We specify the gross floor area. So I'll say 6,000 square meters for this one, and then click next. And now it asks us to define the scope. So here we can choose which parts of the building we do and don't include, and a bit more about the structure and the makeup of the building. And so Carbon Designer 3D can be used in a number of different ways. While it's of course very good for the early stages to do a full building LCA, which I will in this case, you can say for example, you were doing a retrofit. Maybe you're keeping the foundations, the structure, the ground floor slab, and you're just focusing on these aspects here. Well, then in that case, you just include the things that you want to analyze. And so it can also be very good for comparing a retrofit option with a new build, because you can produce these designs very quickly. One other thing that it's quite good for is if you have a Revit model, which might be lacking certain pieces of information, such as the services. In this case, you can actually merge the data coming from a Revit model or any other kind of BIM model with the data that's coming from Carbon Designer 3D. So you can give yourselves quite good assumptions for what the sort of impacts of the services might be. So in this case, I will include everything. We can specify the number of floors above ground level. So I'll stick with 5. You can choose or you can apply whether there's any heated flooring. And then here we can actually choose from a number of different structural frame options. So we've got a number of concrete frames, there's a steel frame, and there's also some timber frames there. I'll then apply some piling lengths. This is actually just for visual purposes, so it won't affect the results. But if there are any special types of foundations, you can input those too. I'll now click next, and we can really start to see what the software is actually doing. So it creates this, what we call a shoebox design of building. So it's quite basic at the earlier stages, but the reason that this is still relevant is because what you're really trying to do is hone in on what the sort of impacts of the different material buildups are. And so even if you had maybe a more asymmetrical style of building, if the quantity of the materials is the same, then the impact of those materials is pretty much going to be exactly the same. So you're just trying to hone in on what those impacts are. You can, of course, bring the design as close as possible to what your actual design might be like. You can bring the 3D model as close to what your design might be like, so you can adjust the height, the width, the maximum spacing between columns, the kind of internal floor heights. And then once you are happy with this, so if you have a basic massing model, you can click calculate areas, and then you have a much broader scope to start adjusting the dimensions. And so it's actually worth noting that this form of building is not necessarily exactly what the building may be like, because you can adjust these figures to be simply not applicable to the shape of this building. So if you do have floor slabs that are maybe slightly larger, you can of course just apply those dimensions, and then it will analyze the quantities of materials relevant to that. So the data that you input here is the most relevant. So you can adjust things like total floor slab area, total length of columns, the amount of area the windows cover on the facade, and also things like the amount of area the services cover within the building. And so again, once you're happy with all of the information you input there, you can click next. It then asks us for a template. So you can create templates to set you off from an initial starting point. So if there's certain design or material buildups that you use quite often, you can actually save them. So every time you do start a project, it's going to save you a bit of time from having to adjust these. But for this demonstration, I'll not use a template, so I'll click submit. Once I hit submit, what the software is now doing is it's looking through or it's taking our building, all the inputs that we've defined, and it's applying material build-ups to all of the different building elements. And so it's doing this by looking at the reference building. So of course we chose the UK, the building type, and also the frame type, but also some of the dimensions as well. And it's applying what it thinks is the most logical or typical material build-ups to these things. And so we now land on the results page, where you can see we've got our building here, which I can highlight with our active carbon view. So it shows where the main hotspots are coming from. And on the left-hand side, we've got a graph showing the tons of embodied carbon by building element. So floor slabs are quite high, for example, floor finishes. We can highlight this with the materials by classification and by total. And so currently I've only got one design included in this, but we can actually have up to 4 to compare. So either I choose a design that I've done before to add to the results section. I can create a new one like I just did. So in this case, maybe we want to see what the impacts would be of a very similar building, but maybe with a couple of extra stories, or maybe a different frame type. But alternatively, I can actually just copy this design directly. So I'll go here, and now we'll have 2 identical designs right next door to each other. So you can see we've got both of them there. And when I come back to the graph showing by element, the graph has become stacked. So any changes that I make will now be reflected. So what I'll do is I'll come to my design 2, change the floor slabs in there. So if I make sure I have my second design selected and show all elements, I can either scroll through all of the elements, and these are all of the building elements with their material build-up applied to them. But I know if I come onto the structure, I've got floor slabs at the top here. So a hollow core concrete slab has been what's been applied to it. I can actually edit the individual materials within this, so I could choose between different forms of reinforcement, different insulation types, and I can also adjust some of the thicknesses in here. But what I can also do is if I click Edit Floor Slab, Show Unused Resources, I now have a selection of different materials that I can choose for and apply to the building. So maybe maybe I can have 80% wooden joist and 20% hollow core concrete. And in fact, if I scroll even further down, you have a number of other floor slabs to choose from. So one of the aspects in the main One Click LCA software is that you can create and save what are called constructions. These are material build-ups, and you can save them to your account, so you can use them on various different projects that you do. So if there are certain details that you use quite often, they will also come up in Carbon Designer 3D. So there's a lot of flexibility to kind of customize what sort of information you input into your projects. So with 80% wooden joists, I'll now put 20% hollow core slabs. And once that's finished loading, we'll then be able to see how that's affected our design. Okay. And so if I come back up to the graph, you can see what sort of change has occurred. And so that's reasonably significant. I've managed to reduce the impact of my design by about 6%. But yeah, this is really how Carbon Designer 3D works. It's very quick, very easy. You're not having to input every single nut and bolt into a design. It's going to populate that information for you based off of typical assumptions. And that's why it's excellent at the very early stages of a project. And so once you're happy with all of the changes that you make, at that point, you would then click Save Design to Project, and it's going to bring all of that data back to the main One Click LCA software, where you can then work on it as if it's just an ordinary project. And so you can generate, you'll be able to generate all the various different graphs, analyzing the data, and also produce any of the sorts of reports that you might need. So in this case, I use the BREEAM tool. For BREEAM, obviously, creating benchmarks and early stage designs is very useful. So this can be something that you produce your baseline designs from very easily and very quickly. And so that's that for the demonstration of Carbon Designer 3D. I'll now hand it back to our guests. And I think if I click that, we can now go on to the slides. Okay.
All looking good. Thank you very much. So just go through some of the case studies that we have done internally and how we've been able to help clients with the early stage optioneering. So as you see, the Carbon Designer is really versatile. I like the way that you're able to select elements and have per square meter allowances in this kind of time when people aren't too sure what kind of detailing they want to go for, or if there is like no cost plan or no BIM model. Really nice early stage. So this is an example of something that we did in the city of London. So we had an existing large office building that wanted to go through a rejuvenation to really give more holistic environmental goals to get here, to give a better floor area for the tenants, etc. So we were able to make this graph here, basically showing what would happen if we were to have the building business as usual, fossil fuel plant. What if we were to go for a brand new building? What would the impacts of that be? And various refurbishment options. And I think one thing to point out here on the left that's quite good is that you can see where the initial carbon parity happens. So we can see where almost your carbon return on investment comes into play. Also lets you make a more informed decision on what options you want to go for. You may find that the carbon differences between a couple of options may not be so large, but it will enable a lot less materials that need to be replaced during operation. It might allow you to have new greening on the outside for your bionet gain targets to be met. So this is all very early and preliminary information as part of this building. And then you can whittle down your options down to two main ones. You can see how they compare, and you can see where you're expecting those carbon jumps from where you're starting to replace large amounts of material over its 60-year lifespan. So for instance, when the plant needs to be either replaced or refurbished. It also allows you to see the modular breakdown of the upfront carbon, replacement carbon, and gives you that first idea of where you sit against the goals that you want to set either internally or are set as part of the GLA guidance. Shift onto a more industry-wide case study. So fit-outs. You can do fit-outs, you can do LCA on fit-outs, and they have their own unique challenges, but pros as well. A lot more detailed design and consideration of, say, things like finishes. So we're seeing a bit of a market shift, with people getting a bit more wary of the fact that when you are fitting out to Cat A in order to sell a prospective project to a tenant, a lot of those suspended ceilings, a lot of the lighting and HVAC can be just taken out. Because of the time and the cost implications, there's not too much either reuse or retention of those. They want their own bespoke designs. So using the square meter averages as part of the One Click LCA, but also being able to put in our own bespoke designs if we have them to hand, we're able to calculate the carbon impact of if you were to fit out or not. So here's some of the solutions. These graphs are from those case studies. And for instance, you could install a sample area. So we're just showing what it could look like to either sell it or just to say we'll hand it over as it is. You could develop to Cat A+ to reduce the risk of that strip out happening and losing the material that you have expended up front under your own carbon budget. We've seen some quite innovative stuff. So we've seen virtual augmented reality. So there is literally no material going in. And you see here the upfront carbon on the left side, at the bottom showing what would be expected to be retained, but at the top showing what is potentially at risk, and that's per square meter in kilos. That can be quite significant if you've got a large office building. The minimization of the impact as well, so perhaps putting in policies where you have material leasing or take back schemes just to make sure that when it's put in, you're not losing that. And just a little bit of a graph down there at the bottom right, just showing you that when you're optioneering, you can set how long you're expecting your materials to be put in. And really trying to keep hold of materials, using high quality materials can, and a really good, iconic, well-designed, say, office or hotel will allow you to keep your materials for longer and keep that carbon down. Here's another study. So this is an office building in London, and there was an internal ESG target to try and get around that 500 kilos of CO2 per square meter. So with the optioneering, we were able to identify, first of all, the baseline using those very big kind of big ticket items like your concretes, your steels, what you would expect most of your carbon to come from. And then we were able to show, well, if you retain some of the structure, you've got a real saving of your CO2 per square meter. That wasn't enough to get you all the way to the 500. So then you can start using other inputs from other consultants to say, well, what if we were to start taking donor steel structure beams that you can take from either offsite or even reuse from the on-site, and what impact that would be able to make. Raised access floor is a really hot topic. We've got another slide on that as well, and showing how you can really get up there early and be able to bake it into the design before it gets fixed into place. Bringing it more to a granular level, you can do elemental analysis, although it will have knock-on effects on the whole building's carbon. You can break down, say, the floor slab. So a bit like the carbon designer was showing, you're able to choose different preliminary constructions, or you can make your own. So we had a new build lab, an office building in Cambridge, and it really sparked off a good conversation of seeing what could be put into place, but also highlighting some of the barriers that you might come across. So you've got the type response factors are required in lab and hospital environments if you're getting to work that would cause microscopes and very minute movement. So in many ways, the composite and timber for the additional stories adding on to that, it wasn't really sufficient. But we were able to maintain that there could be a roof made of timber. So we were still able to put that within the design and get the carbon saving. Ultimately, concrete PT slab was gone for, but you could also think of ways that that can be impacted by, say, changing of procurement or design. To get to a really granular level, so raised access floor, as I said before, is a really hot topic at the moment. You've got quite a lot of steel work going in and to encase that wood core. Those other cores can be used as well, and there are many manufacturers of raised access floors. And what we're seeing here is that the market for fit out is really looking at, can you retain from the existing building, or can you procure upfront from either refurbishers, there's a very hot demand for them at the moment, or for new raised access floor with different materials. You can really then demonstrate what would happen if you took an average one and you put in those factors. So for option 1 there, you can see the recycled content, and for option 2, you've got a recycled and reclaimed panel. And it's a really visual, it's very quick, and it's really easy to get that win of being able to then say, right, we can really contribute to our carbon goal because we've identified that the raised access floor could be a good point to intervene, and then you can get the costing done and the early procurement done, and you avoid any risk of that being lost later in the design. So another one, a bit more on the MEP side. So lighting, we're looking at a Cat B fit out of a headquarters office in London. Lighting does have quite a high embodied carbon impact because you're looking at changing it quite frequently, just because of the fact that the lifespans are shorter. There's a lot of it being put in, and a lot of the materials are coming from being imported from other countries whose electricity grids are dirtier. So the industry average, there is a square meter allowance again that could be used, or you can pick from a plethora of different options. It really has, in the last year, exploded in popularity. In this sense, we were looking at what kind of innovative materials could be used for option 1 and 2. So looking at, could you blend in biomatter? So we're looking at a paper luminaries mixed in with plastic to give it that reinforcement, or even if you're using a plastic replacement to give that 80%. So you can go into the granular details, or there is just an upfront kind of benchmark per square meter allowance that can be used at a very early stage just to account for any carbon that may come up. And then bringing it more to the core services, being an MBP consultancy, we're very hot on the refrigerant leakage and refrigerant types that we're putting into buildings and considerations around that. So this is over the 60 years, and this is the impact expected from the refrigerant leaking or being replaced, all the servicing required. So we had a major refurbishment of an office building. They were retaining a lot of the existing framework, so very conscious client side that it's got to be a very green building. The early stage optioneering allowed us to identify that there could be a risk to their own internal target, and with the amount of CO2 that could potentially be leaked out, we can mitigate that by putting in a different form of VRF. So the VRF was substituted to a different system that had a bit more water distribution, so you're getting rid of all of those leakage points, and also allowed a different type of refrigerant, which showed a really large reduction up front. And if we were to continue to use that design, if it was picked up later on, then you have the issue that you may have to go through a lot of new designs, costing, etc. So it's a really beneficial part. So that's it for me for the case studies. I'm going to leave something up to Holly to kind of wrap us all up and then go through to our Q&A.
Thanks, Max. So to sum up, why is early stage optioneering important? So we've shown that there's an increasing prevalence across all of the industry standards, shifting from operational carbon to embodied carbon, and that could follow through into the increasing cost of carbon offset. And why should you be doing it earlier in your projects? Because there's the biggest impact to influence the earlier you do it. And then how can you do those early stage whole life carbon assessments when the accuracy is at its lowest? So we touched on there's often not cost plans available, there's very little design information available. So that's where you can be using your One Click LCA Carbon Designer 3D, and that can be your initial starting point, and then you can layer on top any information that you do have available. And then the ultimate question is, what value does this provide? So Max has touched on a few of these, so I won't go into every single one. But the key takeaways is that you can be maximizing your carbon reduction potential. You can have cost efficiency. It improves your design outcomes. It mitigates risk and it encourages innovation. So, for example, mitigating risk, Max went through that VRF versus hybrid VRF system, and that allowed you to mitigate the risk of that refrigerant leakage because you were able to compare the two options. What you can look at market shifting, so all of the different, how we're moving maybe from Cat A to alternatives to Cat A, so Cat A plus or just shell and core, you're able to quantify the impact of those shifting markets very early in the design. You're also able to look at innovative materials. So we looked at how you can have your different lighting options with biomaterials and plastic lighting. And the earlier you look at those innovative materials, the more likely you are that they can become embedded in the design and they don't get costed out, or there's just no opportunity to look at them later on. There's also the ability to collaborate with the design team. So we saw that with the different structural optioneering. Although we had the whole life carbon analysis underpinning the different structural optioneering options, and we could see which one had the lowest carbon impact and which one had the highest, you also have to balance that with all of the different other design considerations. So for a lab space, it just wasn't feasible to have a timber construction on the typical floors because of the response factors. And that was okay because we understood that collaboration with the design team and ultimately went forward with the best approach. But I think in summary, the earlier you do it, the design is much more flexible and you can embed all of these carbon reduction ideas into the design, and you can create a much better, more informed design out of it and help the client with their decision-making process. And I think that is it for me.
Brilliant. Well, thank you guys. That was really interesting to see how you're effectively using the tools that One Click provide. And in practice, that's really cool. So now we'll move on to, just before we move on to Q&A, if you're keen to see more or keen to find out more about One Click LCA and you'd like to book a demo which is more personalized and goes into more depth of the various tools, I believe there's now a poll that should have appeared where you can specify your interest in doing so. So yeah, feel free to click one of the three options there. I think if I click skip, it shouldn't do it for everyone. And now we'll move on to the questions and answers. So we've got a few that have come in now. So anyone else who's got more at this point, or as we are discussing further, please do stick them in the questions chat and we can go through them. But I'll start at the bottom. So the first one from Stuart: when you use the term non-fossil fuel on your graph, does this take into account that 30% of electricity is produced using fossil fuel?
Yes, that's right. So non-fossil in the terminology, so to give that some context, is the talking about combustion versus not combustion at the actual site itself within the actual plant. So that's what is trying to be conveyed there. And yes, we're using grid factors, so it would be grid factors used in the operational energy calculations as well. So there is an accountant in that carbon projection that there will be some fossil fuel in that mix too. So that is very much accounted for. I hope that answers the question.
Okay. Next question we have is regarding the CO2 per meters squared. Cat B illustrated that the 190 kilograms of carbon equivalent per meter squared. Sorry, I missed I'm reading this as if it's being spoken. They missed the type of building and the level of refurbishment. Is that for the B or A rated? How about residential? Which number did you achieve after refurbishment for the B or better rated? I don't know if that made sense to you.
I think I can answer that. So the 190 kilogram figure, that's taken, I think, from the Overbury have just released a cross-industry paper all about trying to quantify the impact of Cat B embodied carbon. And that 190 number, that was the result of the first part of that study, where they found the 190 as the typical Cat B embodied carbon impact. So it's not relating to Cat A, it's just purely Cat B for a typical office.
Okay, great. So the next question is, I think more for myself. Can Carbon Designer 3D be used after the early design phase, in effect, retrospectively? So I think there's kind of two parts to that question. Is yes, it can be used at the later stages. This is what I was talking about, that it can maybe fill in gaps of data that you may not have. There's still allowances to certain levels of inaccuracy while doing an LCA. Of course, if you're doing an as-built, then ideally you're not going to be using any assumptions. You're going to be specifying the exact information that you have for that. But in any case, if you're maybe at the technical design stage or construction stage for doing an LCA, then you could still fill in certain gaps that you may not have. But more often than not, it would be at the later design phases, and you wouldn't be necessarily doing it retrospectively, because as a project develops, of course, more things are going to become apparent as it goes. I don't know if Max or Holly, if you have ever used Carbon Designer 3D for a later stage in a project than just the design phase.
Max, do you want to answer
that? I don't think we have any internal examples of that. I think it would be quite a unique use case. I'm sure you could do it. Absolutely. I mean, say for instance, if it wasn't done early, and then later down the line you wanted a quick accountancy of what the impact of that could be, but then maybe you'd have more detailed information you could use instead. So yeah, it's very much an early stage thing, but a very versatile thing.
Yeah. Okay. So next question is, in your experience, how receptive are clients and stakeholders to optioneering strategies that focus on carbon reduction? And how does optioneering impact cost of the project?
I think obviously it will depend client by client, but we're seeing more so that a lot of clients are having ESG targets within their company requirements. So that's obviously following through into every project that they're working on. And all of their KPIs are being tracked against their sustainability targets now. So I think, yeah, there's different levels of receptiveness, but I think it doesn't also always matter. It's about phrasing it in the right way so that the client is interested in it, because the low carbon choice can also be the most cost effective choice, not always. And the earlier you do it, the earlier you can embed that in the design, because it's always easier to design the solution rather than design out the problem later on. And that definitely happens a lot in the industry. So it's much easier to use minimize your waste very early on, minimize the materials going into that building, rather than going further down the line and trying to procure the lowest carbon steel, the lowest carbon concrete. And that's obviously going to drive up the cost, and it's also going to create procurement issues potentially.
I think that's a really good quote, is design the solution instead of having to design out the problem. That's a very good way of putting it. So I think the next question is kind of similar, so maybe we just skip over it unless you have anything additional to add, but it's how do design teams react to carbon optioneering solutions that are proposed? Do you get much pushback?
To just kind of embellish a bit more, I think design teams are very receptive, and normally a lot more if you work alongside them and collaborate. So instead of just maybe coming up with the solutions and then just putting them out there, getting people quite excited and getting them in and discussing how you can incorporate that, because a lot of like MEP structural and architectural practices are getting really keen on it, because they realize that from their own desk they're able to influence very large amounts of carbon, and it may be something that is not necessarily too difficult to do. Sometimes it is, but it doesn't just have to be a procurement option. There's lots of innovation that even a few things can make a big difference.
Great. Here's quite a particular one. Is there a specific product you used for the plastic low carbon lighting?
I don't know, because I didn't do the study myself, but we can definitely ask our team and they can get back to you on that.
Okay. So next one here is, how does optioneering for embodied carbon influence other aspects of sustainability, such as energy efficiency or resource conservation?
Who wants to go for that one?
You go.
Maybe
that's
both
right.
of you answer, but one at a time. So Max, you go first.
Oh yeah, okay. I think it has quite a large influence on other aspects. So, for instance, if you're going to be putting more greening in, there could be more structural loads. If you're thinking about energy conservation, it's starting to come to a point where triple glazing carbon factors can be a little bit higher than double glazing, and as such, you may have to make choices through them. Would thinning down a U value take priority, or would the embodied carbon take the priority? Green roof, PV, normal roof. Like I said, there are very interconnected and holistic ways of looking at things. And from my past life, for instance, we did a case study on we want to be more circular, so we're thinking for a project, can we reuse this heritage project's own slate on the building still, instead of just getting rid of it, putting in different wastage rates, etc., or should it be the more cost-effective option of importing it from Spanish quarries? So they all come in, and the optioneering against the carbon, it could become very detailed very quickly. So it depends where your priorities are.
Yeah, I think energy efficiency is a really good way at looking at the whole coming together of embodied carbon versus operational carbon, because with the changing grid factors, operational carbon is obviously becoming less and less important. Operational energy is still obviously very important, but it changes the weighting of how you can look at things. And if you look at things over the whole life of the building, so that at least 60 years, probably longer, then it can change the way that your decision-making process works. So triple glazing is a really good example of that. Triple glazing is obviously will create a great thermal envelope for your building and really reduce your operational energy and therefore reduce your operational carbon. But it comes with a higher embodied carbon intensity compared to double glazing. And if you put those windows in at construction and then that carbon's happened, and then your operational carbon is decreasing and decreasing year on year, then it might not always be the most long-term solution to go for triple versus double, because you need to look at the whole life carbon, and it can sometimes change the way you look at your results. The same with resource conservation. So with the example Max gave, where you have your major refurb, your minor refurb, or your new building, now suddenly you can really quantify and value existing materials, because you can see the difference in carbon between having a new building versus a minor refurb, and all of the materials that exist in that building now have value. So you can do things like pre-demolition audits, a great way of looking at that. You can get an audit looking at, is the raised access flooring that's already in your building, can that be reused? Can you reuse your ceiling finishes? Can you reuse your internal partitions in like meeting rooms and things like that? All of that now has value that you can either keep in your existing building, or you can try and refurbish, recondition them and put them into a new building.
And I think if I can just quickly add something on that, is that the value that Holly's referring to is that when the circularity of the building that you're looking at goes hand in hand with life cycle assessment, because if you're reusing something, then you're not extracting any raw materials, you're not transporting it to a manufacturing site, and you're not manufacturing it. So that's all of the A1 to A3 that no longer becomes part of the impacts of your building. So this is where these sorts of things can combine. And so I think we've probably got time for one more question, which is at the top. I know that there's a couple in the chat, but I think we may be low on time. So I'll ask this one and see how we do. So what do you find is the best way to manage client expectations as results change in between initial assessments and project phases as new information changes overall results?
That's quite an interesting one. I think it's going to change. The more detailed, the more materials you put in, the more refined it is going to change, either upwards or downwards. It really is project specific. I think two of the things that could be done is just warning up front that can be the case, to make sure everyone's really understanding of the whole process, and then transparency into saying why. If there's a big change, why has it happened? Is it because a particular product's come in? Is it because we got more information, or something big has changed? I can understand how it can be awkward to have one figure and suddenly in the next design stage go, oh, and here you go, it's 70 kilos higher. So I think there's just a lot of transparency and education in that can help mitigate that problem.
Yeah, I think Max is right that you need to be very transparent about where all of your data is coming from and what level of accuracy all of that different data has. And then I think it's really important to, what I was saying earlier, with focusing on those relative results. So you may not even need to put the absolute numbers in your graphs. If you're just saying you have your baseline and it's reducing 10% with one kind of material is increasing by 20% with another kind of material, that is enough to inform your design. And if you take away those numbers, then they're not able to focus on that. And maybe early on, you just make sure that you're setting your benchmarks, but you wait till later on until you focus on the actual detail, and then they can't focus. That's how you can manage the client expectations.
Super. All right, so I think that wraps up the questions now. Thank you, everyone. That was a really good set of questions, actually. And so now we'll round off the webinar here. And so just before we move on, if you're keen to find out more, you can scan this QR code, and there is another webinar that's taking place at the end of this month. So advancing decarbonisation by design with our CEO Panu Passanen and ACOM. And so in this, they'll be running through, actually, I'm not entirely sure, but it will be good to see how that goes. And then, and so you can scan the QR code to register for that session. And then the last slide here is if you want to stay in touch with any of us, here are our email addresses. And so feel free to reach out to any of us and have further discussions, either with Max and Holly about getting some of your projects decarbonised, or maybe their methodologies, and you can find out more about that. Or if you want to find out more about One Click LCA, you can reach out to me here as well. And so thank you everyone for joining. I hope that was informative and you learned something from today. And I'd like again to say thank you to Max and Holly for joining us and running through their projects. That was very interesting.
Thank you. It's been a real pleasure.
Thank you. Have a good day. Bye.
See you all.